Today we are going to talk about infinite chocolate puzzle, which is going viral nowadays in the math world. So we'll talk about infinite chocolate puzzle in which if we take out a piece and we rearrange the chocolate, it remains the same. Right? On your screens, let's imagine a chocolate bar there. We are going to cut this chocolate bar into two diagonal halves. So now we have a chocolate cut into two diagonal halves. To understand the area concept related with this chocolate buzzard, we are going to divide it in four parts like this. As you can see on the screens, two of them are triangles, and mostly we are going to study them only. Right? Let's let's say you add this piece of chocolate, and as you might get caught if you are eating some chocolate in it. So you don't want to get caught, and you are going to rearrange this chocolate into such a way that boom, now the missing piece is not that nobody can catch it. If you did this, you are going to get out of the stage. Fine. So this puzzle is there. You give it a try before moving to the solution directly. Rather give it a try and wonder what went wrong and what could be done. What are the things that questioners are trying to test you here. Give it a shot. Okay. Now I'm considering that you gave it a try and came back later. So let's get started. Let's check if your solution is correct or not. Okay. So for the calculation purpose, we are going to talk about the base and the height of those two triangles, starting with the purple one. Okay. From the grade, it is almost clear that the base and the height of the purple triangle is 5 and 2 units respectively. We are going to talk about the dimensions of the blue triangle as well. Just like how we did with the purple one, it is almost clear that the base is 8 units and the height is 3 units. Notice that the purple triangle in the 2 unit of height and I unit of base is having the angle theta. We are going to call the rightmost angle of purple triangle as theta. Right? And now we are going to talk about tangent of the angle theta. Tangent is basically defined as the ratio of opposite side to adjacent sides. As you can see it on your screens, tangent is the ratio of opposite sides to adjacent side. Substituting the values of opposite side, you can see that the opposite to the angle is 2. They are opposite to each other. And right next to angle is 5. So the tangent of theta is 2 over 5. Calculating it using the function arc10, popularly known as tan inverse of 2 over 5, you get theta equal to or approximately 0.38 radians, which is nearly 22 degrees. So the theta angle for the purple triangle is nearly 22 degrees that you can see. Let's move back to the original diagram we started with. And now we're going to talk about the blue triangle. We know that the base and the height of blue triangle is 3 and 8. So for the blue triangle, we are going to call the rightmost angle as alpha. For the purple one, we called it theta. For this one, we are going to call it alpha. So if we take the tangent of alpha, it is going to be 3 over 8. Because it is the ratio of opposite sides to adjacent sides, just like how we did for the purple one. So if we take the inverse function of 10, or we can say arc10 of 3 over 8, we get the value of alpha nearly 0.358 radians, which is nearly 21 degrees. We can round it off to nearest ones and we can call it 21 degree. So for the blue triangle, the angle alpha is 21 degrees. Now we move back to the original diagram with both these values of these angles. You can see that the angle, rightmost angle of the purple triangle is nearly 22 degrees and the rightmost angle of blue triangle is nearly 21 degrees. For a straight line, if the initial diagram that we were talking about, if it was a right angle triangle, this cannot be the same scenario. Because if we are getting two different angles, that means the straight line is not really a straight line. There is a deviation of 1 degree. So we notice that the theta is 22 degrees and the alpha is 21 degrees, almost nearly. Therefore, theta does not equal to alpha. Therefore, we can say that this is not equal to that. That means it is not a straight line. Let's say if we don't want to talk about all these things, we can also approach this problem or this puzzle without relating with trigonometry. So we will just talk about the base and the height, right? For both the triangles, if you just compare the ratios of their heights to base, it is 2 over 5 and 3 over 8. You can simply say that 2 over 5 is not equal to 3 over 8. That means these two triangles are not similar to each other. We are referring to a topic from class 10 in India in NCERT syllabus. So 2 over 5 is not equal to 3 over 8. Therefore, this is not a straight line. The hypotenuse that we thought it was a right angle triangle is not actually a straight line. It is a tilted line. It is a line like this. One of it is, there is a fourth vertex and this is not actually a straight line. So how we can figure it out? Let's move back to the initial diagram that we started with. Okay. So you get a better idea. So we'll now move on to the initial diagram. And then we will draw the line once again. If you draw the line once again, you will notice that the shaded region, which was the part of the chocolate, is now crossing the line. It is just a little more than the line. That means the chocolate is a little more than half of it. Now, if we talk about the rearrangement to hide that missing piece, we notice that there is a gap in between the line and the shaded region. That means that there is a little less than half of it. So earlier, the chocolate was a little more than half. Now it is a little less than half. Therefore, we can clearly visualize that there is some difference, which is compensating this missing piece. See, it is not always necessary to divide it into two halves. Rather, we can actually use some other dimensions of the triangles and all the other pieces as well. So I have reshaped the chocolate into this kind of parts. So now it is not cut into half, but I can still do the same thing, right? And this time, as I have taken the lower, smaller values, you will get a better idea, better visualization of the difference that we were talking about. Now see, here also I'm going to take out the same piece. Notice that the shaded region is right now a little more than the hypotenuse of the imaginary triangle that we are talking about. So now, let's take out that piece. You ate it. And this time you are trying to hide it. Okay. So let's do the rearrangement. Let us draw the same line once again. You will notice that this time the shaded region is not crossing the line, which is the hypotenuse of our imaginary triangle. Let's go back to the original triangle. So in conclusion, we may say that this is not really a triangle. Instead, it is a quadrilateral in disguise. Okay. So that's it. That's it for the infinite chocolate puzzle. Basically, you cannot have anything infinite and the rules of mathematics stays intact, right? So nobody is going to get infinite chocolate. Some mathematician one day is going to catch them. Okay. So that's it for the infinite chocolate puzzle. Thanks for watching, and as always, we'll see you in the next one.